So hi students, today we are going to see about what is database design and analysis of algorithm. Okay, here design and analysis of algorithms and mainly it is stated about what is meant by algorithm like that. Okay, so here an algorithm is a sequence of unambiguous instructions for solving a problem for obtaining the required output for any legitimate input in a finite amount of time. Here, first the problem to be solved according to the algorithm, then computer program, then we give input as well as output. It is a step-by-step procedures with the input and also to solve the problem in the finite amount of time to obtain the required output. Okay. Next we discuss about next topic is notion of algorithm because the non-ambiguity requirement for each step of an algorithm cannot be compromised. So each step cannot be compromised. So range of inputs for which an algorithm works has to be specified carefully, and also the same algorithm can be presented in several different ways. We have some algorithms in one way, we have to declare in graph or line like that, we have to display the same algorithms. The algorithms for the same problems are based on different ideas, can solve the problem at dramatically different speeds. Here, we have formed a lot of characteristics of the algorithms here. Okay, so first characteristic, what will be the input? So here the input is zero or more quantities. So zero or more quantities are externally supplied. What will be the output? At least one quantity, one quantity is produced. Okay, and definiteness instance, each instruction is clear and unambiguous. Finiteness in a sense, if instruction of algorithm is praised, then all the cases algorithm is terminates after the finite number of steps. Okay, next is efficiency. Every instructions must be basic only, and runs in short time. Here, next we are going to see about what are the steps for writing an algorithm. Here, an algorithm is a procedure. It has two parts. First one is a header part and second one is a body part. The header part is consists of key algorithms and name of the algorithm parameters, for example p1 p2 like that. Then header section has the following sections, and also the compound statements can be enclosed only in braces. For example, you have a compound statement like if, for, while, and is closed only by end of or end for, and while respectively. Okay. The identifier should begin by letter, not by digit. It contains alphanumeric letters, and after first letter, no need to mention data types. Okay, here the first arrow is used in assignment operator, the Boolean operators, or logical operators, relational operators. Okay, the input can be done using read and write. Okay. Next, we are going to see about Euclid's algorithms. Euclid's is basically repeated equality of GCD. Here, GCD is m mod n, where n is a reminder of a division m by n until m mod n is equal to 0. Since GCD of m comma n is equal to 0, the value of m is the greatest common divisor of initial m and n. Okay. Like what here is algorithm described. Step 1, what will be the step 1 here is if n is equal to 0, return the value of m as an answer and stop. So divided m by n, assign the value of remainder to or, and assign the value of m to n and the value of or to n go to step 1. Here this is the algorithm we have now. So first is we have to find two non-negative numbers and also non-both 0 we have to identify. From that, greatest common divisor, like n is not equal to 0 to, then or less tends to n, like m is m and or. And also next we know about the fundamentals of algorithms problem designing. So here, first of all, you have to understand the problem. Okay, then second step is decided on computational means, expert exact versus and approximate solving. Okay, and third one is designing an algorithm. Next is we have to prove correctness, then we have to analyze, and finally you have to code the algorithm. So first is, first, what are the steps we are going to see? First is understanding the problem. This is the first step of designing an algorithm, and they read the problem descriptions carefully. to understand the problem statement completely and ask questions when you are clarifying doubts about the problems. Then identify the problem statements using existing algorithm to find solution, the input to the problem, and the range of the input can get fixed. Okay. Next is decision making. The random access algorithms instructions are executed one after another. They are based to be executed on sequential algorithms. Next is algorithm design techniques. So we have general approach to solve the problem. The first is algorithms plus data structures is equal to programs. And algorithm data structures are independent. Here they are combined together to develop a program. Here, the implementations of algorithms is possible with the help of algorithms and data structures. Now, what are the methods of we are going to specify is one is natural language, another one is pseudocode, the last one is a flowchart. So, what is here natural language? It is very simple and easy to specify an algorithm using natural language. How many times the specifications by using natural language is not clear, we get brief. So, first we have to read the first number, second number, and then likewise we have to read all those things. Next is a pseudocode. Pseudocode is a mixture of natural language and protocol constructs. Here, two slashes is used for condition. The problem definitions. This algorithm performs an additions of two numbers, two integers of a and b. The additions of two integers. Next, the last step of this video is flowchart. So, in earlier days, the dominant method of specifying algorithms was a flowchart. Representative techniques was to be proved to be inconvenient. The flowchart is a graphical representation of algorithm. It's a method of expressing an algorithms by collections of connected geometric shapes containing descriptions of an algorithm steps like start, then value of a, then value of b, then we have to put c equal to a plus b. So finally we have to prove this algorithm correctness. Once an algorithm has been specified that its correctness must be proved, an algorithm must yield a required result for this every legitimate input in a finite amount of time. So for example, the correctness of Euclid algorithms for completing the greatness devices steps from this correctness of equity GCD of m comma n. Here GCD of n is m mod n. It's a common technique for proving correctness is used mathematical inductions because the algorithm's iterations provide the natural sequence of steps needed for such proofs. So needed for correctness for approximations algorithms is less straightforward than exact algorithms. These errors to be provided by the algorithm should not be exceed predefined like. So what is mainly analyzing an algorithm? So here for an algorithm most important is efficiency. In fact, there are two kinds of algorithm here. One is time efficiency and another is space efficiency. A time efficiency indicates how the fast algorithm runs. A space efficiency indicating how much extra memory it uses. The efficiency of algorithms determined by measuring both time efficiency and space efficiency. So factors to analyze algorithms are first one is time efficiency, second one is space efficiency, third one is simplicity, and last one is the generosity of algorithm. Next is coding of algorithm here. So coding and implementations of algorithms is done by a simple programming language like C, C++, and Java. The transition from an algorithm to a program can be done either incorrectly or inefficiently. The implementing algorithms correctly is very necessary. The algorithm power should not be reduced to an inefficient implementation. Statistics like computing a loop invariant, they does not change its outside the loop, collecting a common sub-expressions. Really expensive operations like cheap ones. The selection of programming language should be known to the programmer. Typically, such improvements can speed up the program by a constant factor. The reverse in algorithm selected, a 10 to 50% speed up may be worth an effect. It is very essential to write an optimized code to reduce the burden of a compiler. So here next you are going to see about important problem types. One is starting, searching, string processing, graphic problems, combination problems, geometric problems, numeric problems, like that we are going to discuss in next video. Thank you.